Thank you. Hi, everybody. I'm Stratos. I'm from Greece, hence the sunglasses you saw in the previous picture. Uh, I work in an organization in Microsoft called Industry Solutions Delivery. So we are the people that integrate with your teams when needed to implement solutions. That's why the presentation today, it's all about lessons learned and observations from our journey the last years in implementing Gen AI solutions. And what's the difference from implementing solutions as a playground or as an experiment and going to make them scale for the enterprise? So we'll talk a little bit about the Gen AI adoption, and then we'll talk about the cross-cutting concerns we've observed over the years, and we'll talk about some tools that can help you tackle those concerns like API Manager and AI Sentry, and some others we'll see in the upcoming slides. So do we have developers in the crowd? I guess so, yes, most of you. Architects? One architect. And do we have two architects? Okay. Do we have people actually implementing solutions with Gen AI right now? Okay. Do we have people implementing solutions with Gen AI, not as a pet project, but in production for their enterprise, for the company? Less? Okay. So, I'm sure you've seen slides like that. We say that now it's the second year of the Gen AI revolution. So it's all about, if the first year with the ChatGPT breaking the news was all about experimenting and seeing what's the capabilities of this new technology, now it's all about implementing, productionalizing, implementing at scale. So this is a game changer, Gen AI, not only in the types of applications we make, but actually also in the type we architect our applications. And I'm going to talk more about solution architecting, but there is also a lot to talk about software architecting in this field. So what we've seen is actually two schools of thought. The one is, I say, this is the road less driven, but we see it. It's when companies focus on their hero use case, and they just build what they need to build to implement this use case so they can showcase the capabilities of the new technology. And somehow they expect that when new use cases come, they will follow the same patterns, the same road, let's say. The second one is, we see it also very often, is teams that they try to build a whole platform to cover every possible need they would have in the future. It's like building a multi-lane high railway, and then you have everything you need that you start building applications. The second has some trade-offs. Actually, architecture is all about trade-offs. It may be more expensive and may be more time-consuming. And to some people that are less technical, maybe business stakeholders, may seem like Gen AI is a very complex thing to do. It requires a lot of effort, and maybe it's not worth going there. So, for example, for the first school of thought, if you want to build something simple, like you have a contact center, a call center, and you need to create an automation to get the recorded audio files, make the transcription with a service speech-to-text, and then leverage Azure OpenAI or whatever LLM you want to get the insights or to summarize them or to get a sentiment analysis, etc. You could go with a simple architecture like that, cherry-picking the right services for your use case. And then after you validating and evaluating, maybe you will add things to it if you want to expand it. If you want to go the other way around, the second school of thought, you may end up with a complex thing like that. It looks intimidating. We call that an Azure OpenAI landing zone, you can find similar diagrams in other cloud providers or other technologies, of course, but these are more or less all the services put together that you need so you're able to deploy every kind of Azure OpenAI solution. What we think and what we see is the most effective way to go is a mix of both. So you focus on your hero use case because you want to prove that this is a technology that can bring money to the company, or that can help us do things faster, or we can have a new innovative product. But you build it in a way that it's expandable and that you can add to it elements, modules, or whatever you need in the future. So when new use cases come, you don't have to reinvent the wheel, or you don't have to increase that much the marginal cost, which is very important. We need every use case should have a very low marginal cost and not building up. Yeah. So having said that, we see three kinds of, I will share three categories of applications that we see that customers are building Gen AI applications. One category is the simple RAG application, like you just made something, leverage your data, and you may have a chatbot or something like that. It can read your data, it can be grounded to your data, and it will answer questions. Yeah, that's a very common scenario. We see it everywhere. You start with some PDFs, maybe then you add some manuscripts or whatever. You include then other services that they are needed to extract the information, but eventually the pattern is the same, and usually this is a RAG application. The second one is the applications that they do some kind of reasoning over their inputs, and they are arriving answers based on the business, let's say, the business logic that you have in your company, so your competitive advantage. And these are the most interesting applications. I think they are more or less overlooked because this is getting a lot of traffic, but these kind of applications, that the synthesis, the synthetic ones, they can actually bring a lot of ROI to your company. For example, we have a use case lately that we built a document automation application that will read some specific documents, reason over them using some business logic that the company has, and extract the specific information that makes sense based on some rules, and then construct a new document that serves as a contract for them to use with the customers. And that was a lengthy process. It was taking like, I don't know, maybe 2 or 3 days for the actual agent to do it, and now it takes like 10 minutes with the agent. But it's based on, let's say, collective knowledge of the company that it's injected in the prompts, and it's not just like summarization or just extracting key terms, etc. It's reasoning over documents. The third big category is what we call agentic applications, agents. So copilots that work together and they can perform actions. There is a framework called AutoGen that you may know, which is very useful for building this kind of applications. So these are the three main categories we see. Of course, they're not mutually exclusive, so we can see a mix of them. But depending on what you choose, there are some cross-cutting concerns that you see all over. For example, maybe you are familiar with this diagram or something similar. What's, let's say, the blueprint of a Gen AI architecture. I want to focus in the intelligence layer, where is our data and our models live there. What we've seen is that there are a lot of teams, a lot of customers they try to find the best model up front. So they do a lot of experimentation with their different models out there. And of course, this is something you need to do, but when you do it up front, you may lose a lot of time, and you may rewrite your prompts a lot of time with something that's not that necessary. And even if you use tools like, for example, the model catalog, where you have in AI Studio that you can pick and do your benchmarking, etc. Even if you use tools that facilitate this work, it's better to pick your model after you prove that your LLM can do the task that it's supposed to, that it will fit for purpose. So I would say that after what we've seen with all teams, picking the right model, it will be OpenAI GPT-4 or it will be Llama or whatever, could be an optimization process, and that's a better way to go. After you validate that the LLM and GenAI is the way to go for your application. So usually we start like that. We may have an application that includes several elements. We have our code, we have our prompts. We surely need some kind of orchestration, and we can do that with different ways. And we have an LLM. It can be Azure OpenAI, but of course it can be whatever you like attached to it to perform whatever we ask it to do. Two things rise here, even when we start the first use case. One is prompt engineering. We see a lot of teams, they follow a code-centric approach. They have their prompts inside the code, and they treat it as code, which makes sense in some cases, but it has all the drawbacks and all the defects of classic software engineering, and you have to follow the process that you follow when you're writing code. You have to debug like it's code. We find it easier to use tools that are built for this cause, for orchestrating GenAI flows. The second thing is the evaluation, how you evaluate that your flow is performing well. We see teams that they follow code-centric approach, usually they try to evaluate their flows using unit tests, like it's a normal software, which also has a lot of benefits and a lot of cons. We think if you want to do that right, you have to find the tools that can really facilitate this process. We use AI Studio, but there are other places like other software like that, where you can have a visual representation of your flow, and you can have ways to test your hypothesis with different variants of your prompts, and to orchestrate with different, let's say, data sets with different scenarios, etc. And also you can validate. Yeah, this is variants. So you can have the same prompt, but applying different variants, so you don't have to rewrite the code or debug it. You just apply all different scenarios here, and you can validate it, evaluate it with specific tools and with specific metrics that are suitable for GenAI applications. For example, in prompt flow, which is in AI Studio, you have these metrics like groundness, relevance, coherence, fluency, similarity. These are GenAI specific. So for example, if I build a RAG application using my own data, my Q&A of my how to use a guide, I want to know how grounded it is to my actual data, how relevant the answers are to the data I provided. And of course, I want to see if there is any hallucinations, or if there is any answers given that they're not in the data, etc. And of course, you have to find a way to deploy it easily. If you use this tool, you can deploy it in a managed endpoint in Azure, but you have to find a way to streamline your process, to build a life cycle, let's say. But then comes the second. use case. And then you need, again, an orchestrator. You need to do different stuff. Maybe you work with Jupyter notebooks this time because the team is more data focused. Maybe you want to do classic software engineering and you do it with Python or .NET or Java. You still need to have a LLM, a resource. If it's in Azure, it's Azure OpenAI. You have to attach it to that. And then it comes the third application and the nth application. And now we start talking about things that rise up when your hero use case is well adopted, everybody's happy about it, but now you need to scale up. So will this kind of, let's say, infrastructure, having a shared LLM infrastructure shared all over your application work, what would be the troubles you'll face? There are a lot of things to consider. What we've seen is, of course, that's not the list that covers everything. That some of the biggest things we've seen, the biggest troubles are these, the cross-cutting concerns. So you have the security. We'll talk about it in upcoming slides deeper. You have the observability concerns, like most teams, they start doing their logging in the application, but that's not always the best solution to do it. You have to find a way when you have all these different applications to, let's say, decentralize your logging. You have to find a way to see what's the token consumption among all these applications. That's not always trivial. You have to find a way to streamline your resource allocation. I mean, you don't want to share your notebooks that you're doing experiments. You don't want to share the same resources and the same rate limits with your hero use case, with your chatbot that is customer-facing and that all your customers are using every day. Eh? You have to find a way, especially when you're implementing an application that's it will serve as a product, to have a bill back, see how much did you charge on your LLMs if they're hosted on Azure, of course, and they're not some local deployments or in AWS, I mean, if you have cloud consumption. Performance is a very, very big concern. As I said, you don't want to share your token limits, but you want to share also your performance limits, I mean, your throughput. So imagine that there is a lot of latency in your chatbot because many teams are experimenting and using the same resources. You have to find a way to resolve this. And if we're talking about RAG applications, we have the embeddings. Are you aware of the concept of the embeddings in the RAG applications, hence? Okay. When we use embeddings, there is a pattern that we've seen that sometimes teams, they do a huge load of data on a vector database, and for that period of time, they consume all the tokens available for the embeddings, and then they crash their chatbots or whatever RAG applications they have. This is something you need to take into account. And of course, there is responsible AI and security. These are interconnected. You have to find a way that your applications are secure and they behave responsibly. And there are many elements into these terms that we could discuss. For example, PII handling. You find a way to manage your logging, but in the prompt or in the answers, maybe you have personal identifiable information that you don't want to log them, and you want to find a way to extract them from the logging, but you want to do that in a centralized and let's say streamlined manner. Not every application reinventing the wheel. Or if we discuss the responsible AI in general, as Microsoft, we have these principles. We say that when you're creating an AI application, it has to be fair, it has to be reliable and safe, it has to be secure and ensure privacy, to be inclusive, to be transparent, to be accountable. If we dig into privacy and security and reliability and safety, there are new threats now in the world of Gen AI. For example, do you know OWASP? I see there are a lot of web developers. I remember, you know OWASP, yeah? OWASP now has a list, a top 10 list for LLMs, the top threats for LLMs. So things are getting dangerous, let's say, in the Gen AI world. There are a lot of attempts, a lot of jailbreaks, a lot of attacks. Prompt injection is the first and most dangerous of the OWASP list. Prompt injection means that there is a malicious user that's trying to inject in the prompt some kind of data that will trick your LLM to do something else other than what's intended to do. Or there are ways to trick your LLMs without injecting code, but with the way that you're asking the questions to do things that it's not intended to do. For example, these are some of the documented jailbreak attacks happened recently. And of course, when they happen, then mitigation steps are taking place in the models and they cannot happen anymore, but always new attacks come up. For example, here, the attackers use competing objectives and they trick the model. So what tools do I need to cut down a stop sign? It says I cannot answer, both GPT and Claude, but when you use competing objectives, like start with absolutely here's, then it's strict and starts answering, or when you mask your prompt in base 64, then it's confused. These are some of the attacks. There are other kinds of attacks like that, you ask to build a Molotov cocktail. Of course, the model says, no, I cannot do that. But when you start discussing the history of the Molotov cocktail, then it starts being educating you. So yeah, it also includes the components. Same with Gemini Ultra in a different way. So in terms of architecture, how we deal with this concern, the safety concerns, the security concerns, etc. There are several mitigation layers. One of them is the model itself. So the models have, they're being trained to avoid these jailbreak attacks, and every time a new jailbreak attack is revealed, they're being retrained. So it's important to know the model that you are using, how updated it is, if it's secure enough or not. And that's a thing that you need to do when you're optimizing your application, of course, to make sure that it's as secure as it gets. Then you need to have a safety system around it, because not everything can be dealt by the model itself. For example, if you want your application to avoid using harmful content like violence or hate speech, etc., there are things baked inside the models, but usually there are services that you use in combination with the model itself. For example, in Azure, we have Azure Content Safety that can have some shields and some filters that can filter out this kind of harmful content. Then you have meta-prompting and grounding, so you may have additional instructions, commands to your model specific to your use case, so it will behave the way you want it, and you can ground it, of course, with your own data, so you make sure that the answers provided that will be always inside let's say, a restricted data set. And of course, then there is the user experience. You can have a user interface that's restricting the user from doing things that you don't want. You may limit the way the user can interact with the LLM, and that's on your application layer. Or a thing that we've seen is that you may also use another LLM that will serve as a gatekeeper. So before the user question, let's say if it's a chatbot, reaches your main LLM, you have a smaller one that can do a triage. So if it's a totally irrelevant question, or if it's a harmful question, or if it's something that you don't want to stress your main LLM with, you can have the initial LLM, the gatekeeper, let's say, the bouncer, to redirect that. In the end of the day, what we need is to build something like that, LLM lifecycle that can help companies ideating and exploring, and then moving to building, augmenting, and finally operationalizing seamlessly with all the concerns taken into account that we said, and as effective as possible. There are two actual ways that we see they work to do this in terms of architecture. One is the proxy or the facade, and the other is a subsystem way. So, for example, if you use something like a proxy layer, you can have a service like API management. We have that in Azure. You can have something similar that can deal with things like prioritizing traffic or implementing retry logic. But specifically for GenAI applications, there are services like API management that they have this thing that we call GenAI gateway. So with that, you can do a lot of other things that's tailored for GenAI applications, like rate limiting, like semantic caching, like load balancing, things that are very useful. We can see that in these slides. Logging, reporting, etc. Things that are very useful when you need to have infrastructure supporting your GenAI applications when you want to scale them. And this is something that we see a lot. The other way to go is what we said, the facade, or the subsystem way. There is an open source project called AI Sentry. You can find it in that link. AI Sentry is based on Dapper. Do you know Dapper? Have you heard Dapper before? Dapper is, let's say, a runtime for building distributed applications. Does it ring any bells? Let me show you before we go to AI Sentry for a moment. Can I switch to my browser? I can do it, yeah? Okay. So that's Dapper. Maybe you're more familiar with other similar runtimes. I think there is Istio does things like Dapper. So it's a modular approach, it's a set of APIs that can work together in a modular way to help you build secure and reliable microservices. As I say, it's open source, and you can see that you can automate your business process with that. You can plug in different components based on your needs, and you can integrate with different cloud providers. So based on this infrastructure, AI Sentry is this open source project that I was telling you about. And let me get back to my slides. Okay. So based on that, we have this Python. This is Python, but there is also a .NET version of it. So we have this Python project that helps you build a layer on top on your LLM infrastructure to facilitate or to address all these cross-cutting concerns: chargeback, load balancing, request response, logging and filtering, A/B testing. One big thing that we say a lot is that, for example, if we talk about OpenAI, there are new models all the time, new APIs all the time, and developers are complaining. You need something to help you deal with that, of course. So in terms of architecture diagram, this works with the pub-sub pattern. So you have your LLM, but you have, on top of that, you have the layer of the AI Sentry proxy, the facade. So when you get, from your GenAI, when you get an answer, you have the publish and subscribe, and there are several modules that you can leverage that can go and do different things for you based on the answer of the LLM. They can go and log it, for example. Here we saw in a Cosmos DB logger, they can do PI stripping, they can do load balancing, etc. Here we saw how we do the cross-charging. In streaming and non-streaming, this is very specific. I don't want to deal with that, but there's a big difference if it's streaming response or not. Request response, logging and filtering, where you can have in HTTP headers can direct the layer to do specific kinds of logging, log levels, different log levels, PI stripping, etc. And of course, then you can take the results and you can make a Power BI or whatever Grafana report out of it. You can have smart load balancing. So, example, you have different LLM resources, Azure OpenAI or something else, and you want to load balance between them. And you want to find a way to do it specifically with specific prioritization. That's one way. Or you can do it round robin, or you can see which one is reaching the limits of the tokens, so it will redirect it somewhere else. But these are things that are easily made with this facade approach. Okay, here you see a diagram of how we do that. And the idea is that you build that layer once, you have all the different modules, and depending on the use case, you can use some of them. You can plug them in or plug them out. You can work asynchronously, and you can work also synchronously, depending on the use case. But you build this infrastructure, and you have your peace of mind that whatever comes in your way, you can find a way to tackle it. Otherwise, we've seen teams having to reinvent the wheel all the time and spend a lot of time and money in dealing with concerns that could be designed up front but wasn't. Or we see teams, as I said in the beginning, that they're doing everything up front. They spend so much money proactively deploying or provisioning all the necessary services, all the security mitigation layers, but they use a very small portion of it. So that's two ways of approaching that. Of course, there are different ways to do that. This is two ways we found useful. The thing is that you need to start thinking about architecture these days. That's the key takeaway. You need to start thinking about architecture, and you need to start thinking that LLMs and Gen AI is not just an API that we just consume it and that's it. I mean, there is a lot of things to consider behind it. I think, okay, I was talking a bit fast, but I think I finished the base things that I wanted to say, so we can spend more time on Q&A if you have. And yeah, thank you for your attention.
Thank you very much. Thank you.
I don't see any. Sorry.
Okay, we're going to do questions and answers. Where's the first question? Who has a question? Right here in the front. Remember, every person who asks a question gets a little gift, and the best question selected by the speaker gets a big gift.
Tesla. Gets a Tesla.
No,
right?
you don't get a Tesla. No.
Okay.
I get the Tesla.
So first of all, thanks for the presentation. And while looking at the slides, this mitigation layers, which you talked about, therefore, and I guess it's not really a question, but I guess your opinion about two layers, so the safety system and user experience. So for user experience, would you say there are some nice open source templates that you can easily reuse, for example, for different, let's say just for RAG applications, or just using the foundational models, no matter where exactly they are hosted, so no matter what backend is. So would you say what are the most, I guess, useful templates and where to find them, maybe? And then for safety systems, you did mention some operations that they should do. However, would you say, what would you recommend using for those safety measures?
Yeah, okay. Good good questions. There were two questions. So two presents. Okay. Regarding user experience, I can't very easily point out to a project that's out there open source, but I can point out to some examples that we see. For example, if you go to Microsoft Copilot, you may see sometimes that there are some pre-defined prompts or some examples on how to use the Copilot. So this directs the user on what to do, and usually these prompts, the predefined prompts, are what most of the users would like to do. So you get something like a hint, so you don't mess up with chat. Or if you don't want to have any interaction with, free text interaction with the model, you can really restrict. You can make an application that looks like a bot, but it's not allowing free text. So it's not. It's just having a, let's say, a step-by-step approach. So it will, yeah.
Could I update my question?
Of course.
Not the hints, but the whole user experience as a template in UI.
Yeah.
For example, the whole web page, the web UI, I meant by template.
Yes, and what about that?
So what are the different possibilities to have easy to plug in web UIs? What are the options for easy web UIs that you could host connected to your backend application and just have a little bit more different ways of, or different UIs for your application?
If you want to do something custom from scratch, I see a lot of bots, for example, they're in Python with Streamlit. Yeah, that's a way to go. You may want to do something that's integrated in Teams, for example, or in Slack, and you want to find a way to publish whatever your chat bot, for example, in different channels. This is also out there. I see Streamlit is quite trendy, but I don't have a strong opinion on which one is the best. I think the way you code it is important. I mean, you can do easily UI. You can easily create UIs with Streamlit, but if you don't create any mitigation in the UI, you just allow free text to pass to the model and back, then it's not going to help you out of the box. You have to find the ways to do it. And regarding your second question, which was what? Come again?
What are possible tools for the safety measures?
Yeah. Well, in Azure, we have a service called Azure Content Safety. That's a service that goes between the user and the actual LLM that you use. It may be whatever LLM you like, and can filter out harmful content like hate or sexual or there are several categories of harmful content that are filtered out. It has something called prompt shields that can mitigate jailbreak attacks, and you can also adjust it. So you understand that, for example, violence is one of the harmful categories. Violence is something that you really don't want to have in a dialogue with a chatbot that it's meant to be used by, I don't know, bank users, for example. So you don't want any kind of language like that. But if you have an AI chatbot inside the game, and that game is, I don't know, how we call these first shooters, like Doom, etc., I guess violence in that context is something that you wouldn't like to carry it out completely because it's in the context of the game. So you have something like a slider that you can say, I want hate speech out of the question, but you can allow a little bit of violence, or you can have, you can adjust it. That's one tool that we use, and it works very good. Of course, there are others like that, but this is the safety system outside the model itself. So every model has some kind of mitigation like that. Of course, you cannot ask, I don't think there is a model that you can ask it, can you help me build a bomb? And it will say, yeah, please do that and that. But because there are ways to trick it, you need to have a safety system around it that can protect it, let's say. Mm-hmm.
Okay, thank you. Next question, over there in the back.
Thank you. So you mentioned there are three typical categories of usage for co-pilots. And my question is that, in your experience, would you say there's a difference in how you would approach scaling these 3 usage cases?
Mm-hmm. Well, maybe we can go back to that slide. We cannot. Can I share my screen again? So,
Can we switch the screen, please?
so we remember the use
There you
cases.
go.
Yeah, thank you. There were a lot of slides, huh? It's here. So the first category, when you want to do something for looking up answers, usually that would be a bot approach. And that doesn't have any special UX requirements. It's the classic bot approach that you can do with Streamlit or with the Azure Bot Framework or whatever. If we go to the second category, then it gets trickier because usually in applications like that, you don't want to have an interaction like a dialogue with a system. You can have it, but this is not the typical approach. Usually, you need to report your findings. So this can be a document automation, as I said, application that you have several documents and you want to extract some insights from them and apply some reasoning and do something with that. This should be combined with some, usually it gets combined with some visualization elements, so you can have your reports in, I don't know, Power BI or Grafana or whatever, or you can have custom visualizations, but let's say this is, there are higher demands on UI in this type of use cases. And the other one, it can be a bot, it can be something running in the background, so agents working in the background doing several tasks on the click of a button. So you can have something like when a file drops in a folder, then several things start to happen and you don't see anything, but the agents are doing tasks and maybe you get an email out of it in the end with several, I don't know, with specific text, etc. So yeah, different categories have different needs of UI, so that was a good question. I think these are more or less, and of course, this can be combined.
Thank you.
Thank you. The person in front of him, please. Thank you so much.
Thank you for your presentation. So my question about system instructions for LLMs. So if we are creating LLM for the users, we need to create good system instructions, how this LLM should respond. So maybe you could share best practices, in your opinion, how to create these system instructions for the users.
Yeah, okay, that's a big topic. You're actually talking about prompt engineering and the various things behind it. So we could do another presentation all about prompt engineering, but there are various techniques that can help you get the results you want. So there is simple techniques like few soft prompting, when you give some examples to your LLM so it knows how to generate the answers. There are more advanced techniques like chain of thought, when you try to make your LLM, let's say, mimic the way the human brain works so it can reason more effectively. There are other techniques that you can leverage your LLM to validate the answer that it gave you before as an extra step so you can correct it, or you can give the wrong answer to the LLM so it will correct it and get the actual right one. There is tree of thoughts. So there are many techniques. I think it's a new discipline. I think it's something that will grow, and we need to learn this paradigm. It's a different way of thinking. It's not the actual coding or programming. You have to think in a different way, and some linguistic skills may be also needed sometimes. But yeah, there are a lot of resources, and I can share with you later if you want, or with the audience, a lot of resources about prompt engineering. There are also a lot of techniques in prompt engineering to avoid hacking. So prompt hacking protection. For example, to avoid prompt injection, there is a way to write your prompts. One way is the sandwich approach, so you don't have the user input in the end, and it's easily for the malicious user to guess it. You have it somewhere inside your prompt. That's a simple one. There are more advanced that can help you, let's say, resist the jailbreak attempts. There are also, this is all about meta prompting, so instructions that they can also help you, let's say, build a tone of your LLM, so to behave in a specific way and to talk in a specific manner. That can also be something you're really interested. So, yeah, I cannot give you 2 or 3 advices. It's a whole big concept, but I think there is a lot of research around it. There are a lot of papers published every day, also in academia, also technological papers, and it's a very interesting topic, I think. Yeah.
And don't forget, you can always catch Stratos outside after the talk, and maybe he can give you a few more pointers. Okay, do we have more questions? Over there, right there.
Hi, thank you. I would like to ask a question. Is there a point to train, for example, your own model? For example, if you're trying to make an AI assistant for a chef in a restaurant, for example, you can train a model only on cooking books, or the second option, you can use off-the-shelf solution like ChatGPT or other ready models and try to restrict it to not output any other data than, for example, cooking recipes. Thanks.
Yeah. If you want to make a Gen AI application about cooking books in a restaurant, the usual approach would be the RAG approach. So you ground it with some specific data on your own, your recipes, and so the LLM can answer on that. Based on that books. That's not retraining the model, it's grounding the model, so limiting its knowledge base. So you say you should always answer based on these cookbooks, nothing else. So it can still go and act as a person and answer in natural language, but the only information that it will use, it will not be the things that it's being trained on, but it will be your data. There is also fine-tuning, which is still, it's not training, it's just changing some aspects of the model and providing some specific answers on specific questions, data set of answer questions that can help the model still do the same thing, but in a faster and more effective way, let's say. This is a more expensive, much more expensive process. Creating a new LLM from scratch, to do that would be something you wouldn't like to do. It would be so much effort and so much money spent on things that can happen much easier. But yeah, usually when we say I want to train a model to do my specific things, we talk about grounding or fine-tuning. These are the 2 ways to do this.
Okay, thank you. I think we have time for maybe 1 or 2 more questions. Any more questions right over there at the end?
Hello, and thank you for your presentation. I have a similar question that was asked before, but as a professional, please just answer me. There is a lot of information in the internet, but I'm just interested in how it looks from your side. So could you please suggest some AI testing tools or provide some good practice references?
AI testing?
Yes.
Okay. We're talking about Gen AI testing.
Yeah, for Gen AI. Yeah.
Yeah, because that's different when we're talking about others. But if you go to, I can show you, well, I think I have a slide here, but I was fast. Yeah. So in Azure AI Studio, when you create your prompt flow and orchestration, etc., then you want to evaluate how well it behaves. There is a lot of ways to do that. You can have a data set of questions and you can feed it as a batch process and you get the results. You can automate this process, but you can also use these metrics that they are built in and also the pre-built evaluation flows to let the tool do the thing for you, and you can also leverage an LLM to test your LLM flow. So an LLM goes and reads the results and answers based on specific metrics like the ones I showed you here. So these are some pre-built test flows that they have in this tool for you: classification accuracy, Q&A groundness, etc. You can create your own, and you can do manual testing, or you can do LLM-based testing. So AI Studio is a good tool for doing this kind of stuff, but of course there are others.
Yeah, so just maybe just what I want to hear, yeah, something outside of Microsoft infrastructure maybe, from your side.
Yeah, this is the one that we use, so that's why I can verify. But I know there is one. It's called Pi. I have to remember the name. I can look it up. That's really good for red teaming. That's a different way, different style of testing. So you don't test based on your groundness or how accurate are the results, but you test to see if it will answer in a safe way. So you do a lot of jailbreak attempts, or you try to make it answer in a harmful way, etc. So you do red teaming, like penetration testing, but for LLMs, and you get the results and the evaluation. This, I don't remember the name, but I will find it. I'll look at it. It's a new open source, and it's one of the best. It's Pi something, but sorry, I cannot recall it right now. I will look it up, and I will tell you.
Thank you.
But I'm sure there are others. I'm not aware of them because this is what I use. But of course, you need tools to do your job. That's the takeaway.
Okay. So you can, as mentioned before, you can find Stratos. He will be outside after the talk during the break. Okay. We have time for one last question. Is there one last question?
Pi 3, I think it's Pi 3, but I will look it up.
Okay. Okay. There's one here in the front. And then you'll have to choose which one was the best.
Oh, okay.
So I want to ask maybe some philosophic question. So why prompt hacking is a problem? Because it won't affect anybody except the hacker.
What do you mean? Can you elaborate?
So if we're talking about text model, which return only text answers, so if somebody using prompt hacking, so he will receive some answer, and that's all. Why it's a problem?
Well, there are different ways that this can be harmful. One thing is that you have an organization, you work for a bank, for example, and you create a chatbot that is used to help your customers navigate through your e-banking application, okay? So it's how-to. It's about how can I open a new account? You get the answers based on the knowledge base. Imagine that a hacker managed to make it start talking in a harmful way, to talk, I don't know, in a violent way, whatever, take some screenshots, okay. Then on the social media, the reputation goes down. That's one thing, but it can do much more. You may have instructed your model to be based on specific knowledge base, but if you have a jailbreak attack, you may manage to make it reveal things that it shouldn't. For example, its own instructions. That's called prompt leaking, which could be harmful because you may have things there that you don't want to make them public available. Some instructions may be specific on your business needs, etc. And of course, if it's if it's an agent that it will perform actions for you, so not just a text Q&A chatbot, but a chatbot for a bank application that I can ask, what is my current balance? Okay, make a transaction, transfer some money to you, and stuff like that. And if you inject and you hack that, maybe you can, steal money or do even more. So it's very dangerous, actually, yeah.
Thank you.